Alright everybody, you've gotten a chance to do some looking at spontaneity. So you got introduction to some thermodynamics here. We did do some thermodynamics back in chapter 6 with delta H, Q equals MC delta T, things like that. But this is a little bit different things talking about entropy here. So which of the following processes are spontaneous? We look at here. Rock rolling uphill, no, not going to happen. Leaf falling, yep, it just happens all by itself. And once you have water at 100, yes, it does boil by itself. We don't have to, once it's at that temperature, it will boil. So those two things would be spontaneous. Alright, as far as entropy goes, entropy is disorder. So amount of disorder increases. If it's going to increase, delta S is positive. Delta S is positive. So whenever we're increasing our disorder, so like if I take a deck of cards and then that's all organized and then I throw it all on the floor, I've increased my disorder. My delta S in that situation would be considered positive. If I organize something and I decrease the disorder and I organize those deck of cards, now again my delta S is negative. Alright, so here, if I look at number 2, delta H is negative. That means the reaction loses energy, becomes less energetic. That's from chapter 6. Delta S is negative. Delta S is negative. That means that my disorder is decreasing. So I'm becoming more ordered or more organized. So more ordered. So my molecules have become more organized or more ordered. Alright? So that's those two questions. If we go down to the next thing. If I can make that happen. Alright, number 3. Does disorder increase or decrease the formation of gaseous water? Alright, so if we look at our moles of gas, we have 2 moles of hydrogen gas, 1 mole of oxygen gas, making 2 moles of water gas. So what happens here is that the amount of disorder is decreasing because we have less moles of gas and they're in molecule form. So we have fewer individual molecules. We have elements that have joined together in molecules. So our entropy is decreasing. We have less moles of gases and so since there are fewer molecules, moving randomly. Alright? Boy, good writing. Alright, so number 4. As you went through this with your tables, hopefully these went okay. Think in terms of disorder. As an ice cube is melting, delta S will be positive. Will be positive because it's becoming more disordered. Solid is more ordered than a liquid, so it's going to become a positive. Water vaporizing, same thing. We're going from liquid to a more disordered situation of a gas, and delta S will be positive again. If you are cleaning your room, that means you're organizing your room, so the delta S is negative. Remember, delta S is negative when things are becoming more ordered, more organized. Folding paper, delta S will again be negative. We're putting it into a more ordered situation by putting it into the shape of a paper airplane. Right? You see all these different situations here. We talked about this before. Delta H is negative. That makes it exothermic. Positive endothermic, and all the different possibilities in the situations. Sign of delta S of the reaction. If the reaction is increasing its entropy and there's a release of energy, and every time the reaction will be spontaneous. If there's a energy going in, so energy is not released, which is not a very stable thing, and there's a decrease of entropy, or more orderedness happening, then it for sure will not be spontaneous. The other two situations depend on the temperature, which we'll get into. Alright, so for number 2, according to the table, it says there's an entropy increase. What entropy is it referring to? In that case, we are talking about the delta S of the reaction. It is referring to for an entropy increase. Why can't change in S of the universe be positive or negative for reactions 2 or 3? It's because it depends on, delta S of the universe depends on both the delta S of the reaction and delta S of the surroundings. So whichever one is larger determines what the delta S of the universe will be. So you need to know what those delta S's are. So it depends on the delta S of surroundings and reaction. I'm going to write it all down. Number 7. What's the correlation between the sign of delta H reaction, sign of delta H of the delta S of the surroundings? They're always opposite signs. Ooh, I spelled that wrong. They're opposite signs. So if delta H of the reaction is negative, that means that heat is going into the surroundings, and if heat goes into the surroundings, that makes molecules move faster, all around, faster, which increases entropy. So if the delta H is negative, delta S is positive. That's what it means. Delta S of the surroundings is how much the surroundings is changing as far as orderness. Number 8, the sign of delta H determines the sign of delta S. Explain why this is true. I just think I did that. Number 9 on the table, the sign of the one value determines whether the reactions are spontaneous or not. And for this to happen, delta S of the universe must be positive. So just because a reaction happens which will be more disordered doesn't make it for sure spontaneous. So it depends on delta S of the, which we said here, depends on delta S of the surroundings and delta S of the reaction if it's going to be spontaneous. Number 9er, on the table above, the sign of one value determines whether reactions are spontaneous or not. I'm pretty sure that was here. Sorry. Number 10, statement of second law of thermodynamics. This would be entropy, and this would be increase. Moving on. Number 11. Statement made when deciding whether a reaction is spontaneous, you need to consider both entropy and enthalpy. If only one value is needed to determine spontaneity, then why do you still need to consider the enthalpy? Well, the enthalpy, delta H, helps determine delta S of surroundings. And delta S surroundings helps determine delta S of the universe. So that is why we have to consider enthalpy still. Alright, moving on. On the back, why is delta S negative for the following reaction? That would be negative because we are becoming more ordered as we go from 3 moles of gas down to becoming a solid. That is more ordered. So the disorder decreases because of that. So we're going from 2 moles of solid and 1 mole of gas to only solid. So we become much more ordered. So that means that the entropy, or that the change in S is negative, which means it's more ordered. Number 13 would predict the entropy change. Cannot tell, explain why. So letter A, it would be negative. Delta S is a negative number. The reason why is because the total number of moles of gas is decreasing. We're getting less moles of gas, more order in that case, because there's only one type of molecule. There's less randomness. Letter B, we are creating more moles of gas, so delta S will be positive. And letter C, since we're creating the same moles of gas in this case, it's a little tough to tell. It depends a little bit as far as what the entropy is of each one. So that one we cannot tell for sure. We go from 2 moles to 2 moles, and this one is a more ordered gas. I get that, but it is tough to tell for sure. It depends a little bit about what you've got. In most cases, the entropy will decrease in that case because you're becoming a molecule, but it depends a little bit about what you have. All right, as we move down, these data are all coming from Appendix 20 and 21 in the back of your book. Hopefully you found that just fine. And just like in the past, we're going delta S of the is going to equal product delta S of the products minus delta S of the reactants. Holy cow. Reactants. Alright, if you look in the back of your book, they are in joules per mole. So, we have 211 here. We have, that will become the total. This is 205, and this is 192. If I take the 211, minus the 205 and the 192, I will get 25. Whoops, I have to go 2 times 211. Sorry. So I'm taking 2 times 211 products minus both of the reactants, and I would get 25 joules. Do the same thing for these, all coming from the back of the book. 164 joules, and here negative 89 joules. Now you will be looking at a sheet to try to determine the entropy increase or decrease in a bunch of different situations. Good luck!